Another thing we can tell from a graph, other than where we're increasing or decreasing, is the rate at which we increase or decrease, so the average rate of change between any 2 points. Even if you don't have a straight line, you can estimate what that change is. So if you see on the picture here, we've got the curve, right? We've got this curve shape, but we can still estimate that average rate of change. So not the exact rate of change because it's changing as it increases and decreases, but we can find the average rate of change if we go from one point to another by using the slope formula and by figuring out, well, if this is my x value, substitute into your function to figure out what the y value is. So that's why instead of y1 here, it's f of x1, which it's the same thing. And then we can take our other x value and write it as an ordered pair with the function evaluated at that, which is the same thing as y2. So this is the same idea as just finding slope. The notation is just a little bit different because it's not a straight line, it's a curve, and so it's a function that we're working with instead of just an x and a y value. That line that we use, this line that we find the 2 points on, is called the secant line. It crosses our function in 2 places, and those 2 places are the points that we use to find our slope. So let's go ahead to find the average rate of change. Here's our function. So we're going to need to see that f of x equals x to the third minus 3x. And then from a couple different intervals. So first interval is from where x1 is -2 and x2 is -1. And so what we can do is we can take these and write them as ordered pairs. So if our x value is -2, we'd have -2 for x, then we need to figure out y. And then the same idea, if our second x value is -1, we need to figure out y. And to do that, we use our function over here. So if we substitute it in for our first x value, if we substitute this into our x to the third minus 3x, our f of -2 would be -2 to the third minus 3 times -2, and then we would evaluate. So -2 to the third, -2 times -2 times -2 is a -8, and then here we get +6. So that matching y value, or the f of -2, is -2 for that first point. So we found that -2 by substituting into our equation, and that finishes out that ordered pair we'd use to find slope. And then we can do the exact same thing with our other ordered pair. So here we'll find f of -1, which would be -1 to the third power minus 3 times -1. That is -1 plus 3, and that is a +2. So we found that matching y value, or the f of -1, by using that function and simplifying. So now that we have those 2 points, we can use our slope formula. So I'm going to go ahead and I'm going to call this still x1, y1, just because that's consistent with what we've done. Remember, here the y1 would be the same as f of x1, and then this y1 is the f of x2. Oops, these should be 2's, sorry. There we go. So if we find the slope there, then using our slope formula, we'd get 2 minus a -2. So watch the minus a negative there, and then -1 minus -2. So both of those would turn into addition. And if we simplify, that would give us +4 in the numerator and then a +1 in the denominator. So the average rate of change between these 2 points is 4 for letter A. And if we do that same thing for letter B, so this would be a good one for you to just try and see what you get. So for letter B, our first x value is 0, and our second x value is 1. And then we're going to use our function, which is right above there, to find the others. And so here, if we did f of 0, we'd get 0 to the third minus 3 times 0. Everything there zeroes out, so this would just be 0. And then if we do f of 1, we'd get 1 to the third power minus 3 times 1, which would be 1 minus 3, and that is -2. So it'll be -2. There's our ordered pairs, x1, y1, x2, y2, and we can find the slope, which will give us the average rate of change. So this slope would be -2 minus 0 over 1 minus, what we got here, 0. So this would be -2 divided by 1, so that average rate of change is a -2. So for that letter B, we have a -2, which means if I scroll back over, because we have a positive change, a positive slope, we are increasing between my first 2 points, where x is -2 and x is -1. And then over here, we know that the graph should be decreasing because we have a negative slope. So the slope's the average rate of change, which is highlighted here. Here's our first increase, there's our second decrease, if we were to graph and look at that function. So you can use your slope formula to find the average change, and that gives you an idea of if it's increasing or decreasing. And that's just using the slope formula. Next here we have even and odd functions. Even functions are symmetric with respect to the y-axis, which means they're reflected going up and down across the y-axis. And then odd functions are symmetric with respect to the origin, which means it's kind of like they're kitty corner, they're opposite. So it's not just across the x or just across the y. And to figure out if they are even or odd, it is even if when you substitute in a negative value, you get the same function you would if you substituted in a positive value. So f of negative x is equal to the regular f of x. And then it's odd if you substitute in a negative and you get the negative function. So if we do that, determining if they are even or odd and then how they are symmetric, here we would do g of negative x and see if it's the same as this or if it's the opposite of that. And so if we do that, we get negative x to the third minus a negative x. If we just substitute in for x in both of those with a negative x. All right, and then we simplify. So negative to the third power would be a negative x here to the third. And then here we'd get 2 negatives, which is a positive x. Now to compare that, I'm going to factor out a negative. So this would be a negative and then x to the third minus x. And so what we have here is g of negative x is the negative version of the original, x to the third minus x, x to the third minus x. So this is saying that g of negative x equals negative g of x. And if we look back at our rule, that means it is an odd function. And odd functions are symmetric with respect to the origin. So if we answer this, this is an odd function, and it is symmetric with respect to the origin. And you can always graph these. Use Desmos. Type this in your graph, and this is what you'll see. Okay. And it's symmetric with respect to the origin because it's not just flipped across the y-axis and it's not just flipped going straight down. It's flipped at an angle. So it's flipped at this angle here, and that's why it is symmetric with respect to the origin. All right, h of x, x squared plus 1. So if I substitute in and I do h of negative x, that would give me negative x squared plus 1. That means that is negative x squared is a positive x squared plus 1. And these two are identical to each other. There's no negative in my red answer that I have here. So that means that h of negative x is equal to h of x. And that means it is an even function. So I'm looking right up here. We've got an even function, and even functions are symmetric with respect to the y-axis. So this is even. Describe the symmetry. It is symmetric with respect to the y-axis. And then again, if you use Desmos and you graph it, here's what your graph would look like. And notice how it's exactly the same if I draw a line straight up and down for my y-axis. It is the same on both sides, so that is symmetric with respect to the y-axis. So there are even and odd functions, how we can tell those algebraically, and what their graphs look like in terms of symmetry.